Hello and welcome to the AI Research Roundup. I am your host, Alex. Today we're looking at a really exciting new paper called AutoSchemaKG, Autonomous Knowledge Graph Construction through Dynamic Schema Induction from Web-Scale Corpora. The key idea here is to build a knowledge graph, which is basically a massive structured web of facts, completely automatically. Normally, this requires a predefined schema, which acts like a blueprint defining the types of information and relationships. But this new framework, AutoSchemaKG, uses LLMs to generate both the facts and the schema simultaneously, directly from text. The scale is huge. They built a knowledge graph with over 5 billion connections from 50 million documents. And if you want to get your hands dirty with this, the authors have also released all the code. The repository has the full implementation of AutoSchemaKG, with evaluation scripts and helpful Jupyter notebooks. These guides show you how to build your own knowledge graphs or even run what's called Retrieval Augmented Generation, or RAG, using their data. This technique, Retrieval Augmented Generation, helps an LLM ground its answers in facts by first retrieving relevant information from a knowledge base, like this one, before generating a response. Alright, so this first figure gives us a perfect snapshot of the kind of knowledge graph the system, which they call Atlas, actually builds. You can see it's made of different kinds of nodes. The blue ones are entity nodes. These are specific things like a person, Mario Andretti, or a place, Phoenix. The green nodes are event nodes. They capture happenings, like a specific race victory. But the really innovative part is the orange concept nodes. These are automatically generated categories, linking Mario Andretti to champion and Phoenix City, creating that dynamic schema we talked about. So creating these different nodes is one thing, but how good is the system at actually extracting the facts that connect them? Well, this table gives us the answer. It shows the quality of the extracted triples, those little units of fact, across different data sets. It's measured using 3 key metrics: precision, which tells us what percentage of the extracted facts are actually correct; recall, which tells us what percentage of all available facts in the text were found; and the F1 score, which is a combined measure of both. The results are really strong, with F1 scores consistently above 90%. In fact, for event-related triples, the precision is nearly 100%, meaning almost every single event-based fact it extracted was correct. This high accuracy is crucial for building a reliable knowledge base. So we know the extraction process is highly accurate, but this table really puts the scale of the project into perspective. It breaks down the statistics for the different knowledge graphs they built. If you look at the right side, for the large pre-training corpora, these are huge text collections like Wikipedia and the Common Crawl web data. The numbers are just massive. For the Atlas CC graph, built from just a fraction of the Common Crawl data, the system generated over 937 million nodes and nearly 6 billion edges. This shows we're not talking about a small toy example. This is a truly web-scale knowledge graph. Okay, so we've established that the knowledge graph is huge, but the big question is, how much of the original information from all that text is actually captured? This table addresses exactly that. It shows how well an LLM can answer multiple choice questions using only different parts of the knowledge graph for context. The goal is to get as close as possible to the score you'd get from using the full original text, which is the upper bound you see listed. And the results show that the knowledge graph preserves information extremely well. In fact, using both entity and event information together, the accuracy is over 95%, very close to perfect preservation. Alright, so we've seen the graph preserves information very well, but the whole point of this AutoSchemaKG system is that it automatically generates its own schema, its own categories. So how good is that schema? This table digs into exactly that question. It measures the quality of the schema induction for entities, events, and relations. The quality is measured using metrics called BERT score recall and BERT score coverage. These metrics compare the system's generated concepts to human-made ones, checking how much of the meaning and scope they capture. The scores are excellent, often above 90%, showing a high degree of semantic alignment. So the schema quality is high, but does that translate to better performance on real-world tasks? This table answers that by testing the system on multi-hop question answering. which are complex questions that require connecting several pieces of information. It compares AutoSchemaKG against other methods using metrics like exact match, or EM, which checks if the answer is perfectly correct. The standout result is at the bottom. When the full knowledge graph is combined with an advanced retrieval method called HippoRag2, it significantly outperforms all the baselines, achieving the highest scores across the board. This proves the graph's practical value. Okay, so it's clear the graph helps with complex reasoning. But this next table tackles a different crucial question. Does it also make the language model more factual? It tests this using the FELM benchmark, measuring balanced accuracy and F1 score. Balanced accuracy is a way of measuring correctness that's more robust, especially when dealing with different types of facts. And the results show that using the Atlas Wiki graph with HippoRag2 gives the best performance, achieving the highest scores. This demonstrates that the knowledge graph is very effective at improving the model's factuality. To wrap things up, what we're seeing with AutoSchemaKG is really a major step forward. It shows we can autonomously build these huge, high-quality knowledge graphs directly from web text, and that these graphs, in turn, make our language models better at complex reasoning and more factually accurate. This is a crucial piece of the puzzle for developing more reliable and knowledgeable AI systems. That's all the time we have for this AI Research Roundup. Thanks for tuning in, and I'll see you next time. I'm your host, Alex.